Okay, okay, great, great. Okay.
Yeah.
Yeah, sure.
Thank you. Thank you for
Yeah,
joining.
yeah, thanks, and thanks for handling it, you know, at your end well. Yeah.
Thank you, Anjali.
Yeah, done,
Thanks.
and I just
You
speak with
called
Tanvi.
Tanvi.
Yeah.
Great. So she'll start
And
the live at 4. Amit is here.
yes, should I let him in?
Yeah, let him in, let him in. We can
So
just
let the
start.
students also in, now.
I think I'll just discuss with Amit first about the form presentation and then we'll let the students in.
Okay.
Okay. Hi, Amit. Amit has to be made co-host. One second, Amit. Okay. Hi, Amit. Better? Amit, are we audible?
Yes, yes, you are audible. Am I audible?
Yes, you're audible. Were you able to settle down?
There might be a lot of sounds in the surrounding because I'm sitting at Starbucks right now. I
Okay.
can't sit inside and do a meeting. That's why I'm sitting outside.
All right. That's okay, but I think it's very clear. It's just your voice that's heard. So
All
I
right,
don't think
that's
there
fine.
are any
I can
distractions.
only hear the bikes and the cars all around. I think that it is not being captured by the microphone. That's fine.
No, it's not. We're just hearing you. So I think it's going to be great. No issues.
It's all
Amit, I just wanted to know, so you had gone through the form that we had shared today, right, regarding the deliverables.
yes, yes. I have
So do you
changed
want,
my PPT.
uh, no, do you want me to present the form in the end, or would you be doing it as you talk to the students about the deliverables?
Yeah,
Anything is fine.
I'll be doing it by the end only. I have
Sure.
incorporated it in my own PPT.
Oh, amazing. Great. So I think that would be clear for the students as well. So we'll be
Yeah,
here in the background if you need anything.
sure, sure, sure thing.
Great. Okay. So we'll slowly start letting the students in and maybe we can start off in another five
Sure.
minutes.
Just a bit audio check. So I'll be
Sure.
not speaking loud today. So this is
Okay.
how much I will speak. So let me know like if it is clear or not. Okay.
Yes, now it is clear, definitely clear right now,
All
and
right.
there's
So
no
I'll just check
disturbances.
this like hello students. Today we welcome you to our final masterclass, which we are going to have uh, live and all. So this is clear, right?
Yes, Amit, amazing. It's clear.
Now I'm set.
Great. So yeah, we'll let the students in and we can start by around 4, 5 once they've all joined in. So we'll put in the reminders as well.
Sure, sure, sure.
Okay, great, Amit. Thank you. Good evening, students. Thank you so much for joining. We will wait for another 4 more minutes so that we can start the session by 4, 5. Please do ask your friends, anybody who's yet to join in as soon as possible so that we can start on time. It's our last masterclass, so please do come in and let's be ready for our session. Okay, great. It does seem like our attendance is a bit low today. So if there's anybody yet to join, struggling to join, or running forward to join, do ask them to join in soon. And I don't think we'll just wait. Do we need to wait? I'm not sure. All right. So, okay. Good evening, students. Thank you so much for joining. And yes, do join in soon, whoever is yet to come. I hope you are all excited, had a good journey throughout the week for the internship, and you're excited for your last masterclass. I know that there are a lot of queries that I'm even receiving right now regarding the assignments and the deliverables. Everything will be shared today, so don't worry about that at all. So, welcome officially to the last masterclass of our internship of the AIML internship, October 2024. And for our last masterclass, we have our very eminent and lovable speaker that you've all enjoyed for the past 3 sessions, Mr. Amit Tiwari, who is an AI consultant and trainer who has taken sessions over 100, 150 sessions, impacting the lives of over 10,000 students. So, not giving a huge introduction, you've heard the introduction several times. Over to you, Amit, for the session, and thank you so much for joining in once again.
Thank you so much, Anne. And thank you so much for the lovely introduction again. And this is our last masterclass, but not the least. We will be together whenever we have another internship going on. So we'll be keeping you posted. Today, what is there is I'm logged in from Mysore because I'm traveling for different colleges for different sessions. So I have logged in from Mysore today. The weather is really pleasant, and I hope that wherever you are, the weather is pleasant there too. Let's begin our final masterclass, and I welcome you all to the IBM SkillsBuild internship. And today we are going to learn a lot about, we are going to finish the supervised learning methods. We will finish with where we started, that we'll finish logistic regression first. Then we will move on to k-means clustering or k-nearest neighbors. And finally, we will end up this with support vector machines so that you have a solid understanding of all the logistic methods. And also I will be explaining today what is the project that you have to design and how to submit that project. So I welcome you all. Those I am very proud of the people, those who have joined in on time. So we will start this on time and we will finish it on time. Thank you so much for joining in. Let's start our session by sharing my slides, which I have designed particularly for you. I am joined in from my cellular. That means that I have joined in from my data from my phone. So I'll not be sharing the video if that's fine with you. So I'll be just stopping the video so that I can regulate more bandwidth, the audio and the slides that I'm going to share. So I'll share this first slide that I have designed. And sorry. All right, so this is not actually the Masterclass 3, this is Masterclass 5 that we're having right now. And a quick recap of what we have done so far. So we have been learning machine learning. That means that we have been working with data to give the computer the ability to learn without being explicitly programmed. And we have been doing it with the help of data so far. And we also learned that there are 3 types of machine learning: supervised, unsupervised, and reinforcement. And we understood this from example of when you were designing a system where you can classify different kinds of fruits. So if you can label these fruits and you design the system where you are using this label data, that is called a supervised learning. When you use only the data that is not labeled, then you do with the help of unsupervised learning. And when you train it with rewards and punishments, then that's the reinforcement learning, right? So in reality, what we do is we keep a mix of supervised, unsupervised, and reinforcement learning. And when we design any machine learning algorithm, that is kind of like a blend of these 3 learning methods. And what we are doing with machine learning is that we have a data which we call training set, and we are in search of this learning algorithm, which can map our input to output. And we have been doing this with linear regression, where we are trying to find a line which is the best fit or best estimate of that data. And for that, the learning algorithm we require or we use is we are kind of like actually minimizing the error that is there in the predicted output and the actual output. So gradient descent is the algorithm that we were doing, which looks like this. So we are in search of these two parameters. That means that B0 and B1, in which we are minimizing this error. So we start from a point where the error is maximum, and we try to move into a point where the error is minimum. So we take an error function, which we also call cost function, or we also call this the loss function, and we take the square of the error, that is the predicted output minus the actual output, and we try to find these two parameters B0 and B1 so that our error is the minimum. So we take the gradient of the error and we multiply it with a learning rate, which is alpha, and we move into the direction where the error is minimum. And in this process, we are able to find that perfect machine learning algorithm where we are working with data and we are finding the trends in the data to predict certain outcome or to classify our data set into different sectors. So we have been learning so far. What we have done is we have learned about the regression techniques. That means that we are predicting some continuous output out of the X. Now, today, what we are going to learn is we are going to dive in deep into the classification. That means that can we classify our data on the basis of what the trends are there in the data. We have been working on CSV files, and we have been also working on Google Colab, which is a perfect IDE for collaboration. I have been sharing you the templates that you can design your own machine learning algorithms, and we have been coding in Python for the last 2 weeks. So what we have done so far is we have divided this machine learning process, which is a 5-step process of getting the data, cleaning, preparing and manipulating the data, training the model, testing the data, and improving to 3 different phases. The first phase being the data pre-processing stage. That means that we are importing the data, we are cleaning the data, we are splitting it into training and test sets. The second being the modeling, where we are building the model, we're training the model, we are making predictions out of these models, right? And the final one being the evaluation. So we have not touched the evaluation part. Today, we are going to also touch the evaluation part, where we are going to calculate the performance metrics, make a verdict whether our model is perfectly working or not. And then we are going to use that model to predict or classify certain outcomes. We have learned data pre-processing in our last masterclass, where we were dealing with the missing data. So we learned that there are 3 methods of dealing with the missing data. And first one being data removal, data filling using statistical imputation, or data fill using regression. I've already covered this also in last class. And also, if there is a categorical data, we are going to one-hot encode it. Or if there is data like no or yes, which is again a categorical data, we are encoding it using binary encoding. That means yes and no. We have also learned how to do feature scaling. That means that which 2 data sets are near or closer to each other. To find out that, we normalize the data either by using normalization or standardization. Let's come to multiple linear regression, which we learned yesterday, that if there are multiple inputs, then we use this multiple linear regression. We use the equation of the linear regression with different input data points. So that equation of a line changes to a hyperplane in an n-dimensional plane, right? So if it's a 3-dimensional plane, then it will look like a plane. Otherwise, if it go to higher dimension, we'll call it a hyperplane. So we are in search of a hyperplane which best fits this data. So we're in search of these parameters B0, B1, B2, and B3, which is the best fit for the data that we have. We also learned yesterday that about the polynomial linear regression. That means that if the data is not working linearly, or the data has trends which is non-linear, so how to address that issue? So we are feature engineering our data. That means that we are extracting more features of the input. So if X is there, we are extracting more features like X to the power of 0, X to the power of 1, X to the power of 2, depending on the degree of the polynomial. And the degree of the polynomial was a hyperparameter that we are changing according to how we can best fit our data. Right. So if we have a data which is non-linear in this matter, so we extract more features of that data, we fit it into a linear regression line, and that's how we can also achieve regression for a non-linear data. Also, we covered. So today, what we are going to cover is logistic regression. Yesterday, we have covered the intuition behind that. Today, we are going to code it actually. And the k nearest neighbor algorithm, how it works in finding the correct classification of the data, and decision tree regression, that means that, sorry, not decision tree, we will be able to do support vector regression instead of decision tree regression. So support vector machines and how they are effective in classifying a data. So we learned that yesterday, the car purchase problem that we have been tackling till now. So the company TIA is launching a new car and it is in search of customers who will buy that car. So you are called upon because you are the machine learning engineer, and the company says that based on the data of how many people have bought our car, you have to predict which customers will buy our car. And the data looks like this: the age of the customer and whether the customer has purchased the car or not. So in this case, the y is not continuous. It is discrete. That means that it has only two values, 1 and 0. So how to fit a linear regression in this is we are not able to fit a linear regression because we will not be able to find the trends. So a straight line will not be the best fit of that data, right? So what we will do is we will take a sigmoid function, which looks like this, and we will try to fit the linear regression into this sigmoid function. So what we do is we take the linear regression line, which looks like this, and the sigmoid function is y equal to 1 to 1 plus 1 to 1 upon 1 plus e to the power x, and we fit this linear regression to the line. All right, so in place of x, we fit this linear regression line, and if we replace that, what we achieve is a logistic regression actually. So now it has two clusters. That means these customers will buy the car and these customers will not buy the car. So we can actually predict on the base of how much is the age of the customer, whether that customer will buy the car or not. So if a customer is suppose 32 years of age, and 32 years of age, if I map it to a logistic regression, somewhere here, it will be the data point, right? So the customer will not buy a car. And if a customer is maybe 47 of age and the mapping is here, so he will buy a car. So depends on how much, what cluster our customer lies, the customer will either buy a car or not. So it is making a decision on the base of the age of that customer. Now, if we see it in 3 dimensions, then it changes. So we have 2 data points now, the customer age, which is here, and the customer salary. Okay. So on the base of customer age and customer salary, we are predicting whether the person will buy a car or not. So in this case, the y-axis is pointing outwards. That means that all these blue data points are the people who have bought the car, and all these orange data points are the people who do not or have not bought the car. So in the case of 2 variables, 2 inputs, one being the customer age and the other being customer salary, we can fit in a multiple linear regression line in this sigmoid function, and we can actually predict whether the person will buy the car or not. So on the base of the values of y being 1, the customer will buy the car, and y being 0, the customer will not buy the car, right? So we can make a decision on the base of where that new data point lies. So basically we are predicting a new customer. So suppose a new customer has age of 34 and the salary of 40,000. So he lies here, right? So that customer, where that customer falls in the category is how we can make the decision. So we are in search of a decision boundary also. So based on this decision boundary, if a customer falls on this side of the decision boundary, he will buy the car. If the customer falls on this side of the decision boundary, he will not buy the car. So we are basically classifying customers into 2 different segments, one being the people who will buy the car and one being the people who will not buy the car. All right, so this is logistic regression, and in logistic regression, we are classifying or we are categorizing our data into different types of categories. Whether the person will buy a car will be one category, and whether the person will not buy a car will be the other category, right? So let's move on to, so decision boundary separates ones and zeros in the output, and we can also fit non-linear curves, right? So non-linear curves like this. So if we have a decision boundary which is circular in nature, so suppose these are the data points of the customer who buy the car, and these are the data points of the customers who do not buy a car, right? So what we can do is we have learned polynomial regression, right? So if we can fit in polynomial regression, if we can feature engineer x to be of the degree 2, then we can fit in an equation of a circle also, because equation of circle looks like this: x square plus y square equal to r square. So if we can somehow feature engineer, we learned this in polynomial regression, we can also achieve decision boundary like this. So the people who are inside this decision boundary, any point inside this decision boundary will buy a car, any point outside this decision boundary will not buy a car, right? So, or any other categorical data, like whether they will like a product or not, whether they will select a part, whether they will choose buy it a particular product or not, or any categories for that matter. So we can extend it not only to 2 dimension, but we can also extend it to more than 2 dimension, as we saw here, right? So based on the customer age, based on customer salary, these people will buy the car, these people will not buy the car, right? We can extend it to many dimensions, but we will not be able to visualize those dimensions. But according to any type of data set, we can find a decision boundary, which will be a hyperplane in the case of more than n dimensions. And in case of hyperplanes, we can identify which area the new data point will fall, and we can categorize that data point accordingly. So let's code this, because we will be doing 3 different algorithms in today's class. So we'll be coding it a little bit faster. I'm going to paste this code on the chat box so that everyone can access this code. And let's do this there, right? My audio will not be very clear today because I'm working from a cafe, because I've been traveling and taking sessions in different colleges. So apologies for if my audio is not clear. So please increase the volume of your headsets, or please use earphones if you have them. All right. So my audio would be a little bit less clear. Okay. All right. So let's start coding. Thank you so much for those who are saying that the audio is clear. I hope that we finish everything on time today. Somebody is asking where I am. Yes, I am at Starbucks, because they are the only people who allow you to take sessions from outside. So that's why I am sitting there and taking a session. I am at Mysuru right now. Okay. So I have pasted this link in the group chat. You can go to this meeting link and yeah, so you can go to the meeting, go to the link, and it will take you to this folder. You will see it like this. So only data that we are going to use is this car purchase data. So this data you have to download, right? So you download it from here, right? Hope I am sharing the right screen. So you can download it from here, and it will be downloaded like this, car purchase data.csv. If I see this car purchase data, you will be seeing these 3 columns. First being the age, second being the estimated salary of that person, and whether the person has purchased the car or not. So this is the data that we will be working on. It's a data of 400 people who have purchased the car in the past, whether they have purchased it or not, their age and their salary. So we need to create a system where we are trying to identify whether the customer will buy our car or not, so that we can target that customer accordingly in our ads. Okay. So here is the, so here is the classification. And the template that we will use first will be that logistic regression template. So we'll open this logistic regression template, and we will copy this logistic regression template from here. Sorry, I will open it in a browser where I have not done before, so that I can see the same thing as you. So this is a template that you will see. It's a Google Colab template. And yeah, so it will open like this. So if it is not opening, I think I need to make it, I need to make these templates accessible to everyone. So let me just change the share settings. Yeah, anyone with the link can be a viewer. So you'll be able to open this in Google Colab. If it is not opening, then I can just copy the link here and paste it on the chat box so that all of you can access it from the chat box itself. some people are asking for the CSV file. So I'll be sharing the CSV file also in the chat box, which is here, car purchase data. So let me just share the file which does not have this one, but even if it has one, doesn't matter. So car purchase data, it is currently in use. That's why I can't send it. Let me send it again. Car purchase data is all right. So I have sent the car purchase data also. You can download the data set from here, or if you want to download it from this link, you can also download it from the link there. All right, so let's start coding. If you have downloaded the data, if you have the template, if you have made the copy of the template and renamed it according to your name, please send a done and yes in the chat box so that we can pace up this lecture on time. Thank you so much. Those are actually saying done. Abhinav, Rapati, Ritika, Chitrans, Lokesh, Archana, Yesh, Harsh, thank you so much. You're setting up the pace. Avinash is sending me a one. That also is fine. So we need to make a copy on our name. So what we'll do is just type in our name and we make a copy. Now, today we are going to code a little faster. So for importing the libraries, I will go back to my simple linear regression, which I have made. Hope that you also have that open in Google Colab. So you just need to go to Google Colab and open your simple linear regression. Sorry, your file which you have coded. Maybe this file will be there. The first file that we created, which will be just a simple linear regression, and it will be under your name and simple linear regression. So this is it, right? So what we will do is we'll copy today more the code that we have already done. So we are going to import the libraries. To import the libraries, we are importing 3 libraries: NumPy as NP, Matplotlib as PLT, and Pandas as PD. So we'll copy this and we will run this cell. Okay. Copy this from the linear regression file because this is what we have been doing for every session, right? So please copy it from there, linear regression file, and import NumPy as NP, matplotlib.py as PLT, and pandas as PD, right? Second step is importing the data set. So we'll code this. How we will import the data set? First of all, you need to upload the data set here. So upload the data set using this. Let me share the right screen and upload a data set. Data set will be car purchase data, and this is the data set. So you can rename this file here itself. Remove this one from here. If you have downloaded my version, if you have downloaded the original version, which is car purchase data, then you don't need to rename it, right? So you have this. Again, go back to your simple linear regression class. You will just need to copy this second code, which is importing the data set, and you need to paste it here. Okay, importing the data set. And you just need to change this salary.csv to now car purchase data.csv and run the data set, right? Everything will be same. So we now have created a template. Whether any machine learning that you will do, you will use these steps, you will use these libraries, and you will just need to change what data set that you are using, right? So you import the data set. Third is splitting the data set into training set and test set. We have done that too. And that again, we will be copying it from our simple linear regression file. And we copy it from there, come back to our logistic regression template, and we will be done with splitting the data set into training and test set again, right? So we have 3 things. We have imported a libraries, we have imported a data set, we have split a data set into training and test set. Now the next thing that we will do is feature scaling. Why we require feature scaling is because we have this categorical data. So go to the data set again. And I don't think that in the data set we have a categorical data, so we will not do feature scaling. But if we have any categorical data, we will do feature scaling for that, right? So what I have done is I have simplified the data set to remove that column where it was which country the person was from. So I will remove that column. So to make it simpler, so that we can understand it more. But even if we have that column, we now know how to encode that categorical data, right? Using the one hot encoder that we did yesterday. Now we are not going to do that. We will skip that step. So feature scaling we will not do. We'll straightforward go to training the logistic regression model on the training set, right? I hope that's clear. We are not doing the feature scaling because we don't have any categorical data. Sorry, feature scaling is not for categorical data. We still need to do that. I'm so sorry. I'm so sorry that I thought that we are encoding it. We are actually scaling it. And why we are doing that? Sorry, I got confused. I will just share it. Why we are doing that? Because we are normalizing the data, because the values here are too much, right? So we started from 19,000, we have 1,50,000 also as a value. So to work with these values is difficult for our machine learning system. So we will normalize it. We will make it in the value of -3 to 3. So we are doing feature scaling. Sorry, we are not encoding in the categorical data. So we'll be doing feature scaling still. And how we will do feature scaling is that we will go to our template of where we did pre-processing, right? Data pre-processing. So with this we did in our second masterclass where we learned pre-processing, right? Thank you so much, Shubham, for making me realize that we are normalizing and standardizing the data, not one hot encoding, right? So yeah, so here is what we will go for. We will go for this feature scaling only. Okay, so feature scaling we have done previously, so we will not waste time again doing it again. So we'll just copy it from there. Everything will work fine because we have been working with same type of data set and same type of name. So we will just do feature scaling. We will normalize our data. We'll copy that from there, from scikit-learn or pre-processing. We will import this standard scalar, and we create object of this standard scalar. And on xtrain, we'll fit our training set with that standard scalar, and we will transform our x-test also. Right? So we'll just do that, and let's check how our data looks like. So print xtrain. This is how our data looks like now. It has been normalized, and I will also print x-test. All right. So x-test is there, xtrain is there. So it has these 400 columns. So that's why it is like too much of data. I will just clear this output. Okay, so that we can see our code. So now we also can see our code. So this code we already have done feature scaling in data pre-processing template. So this pre-processing template. So from data pre-processing template, we will find where we did feature scaling. So this feature scaling, we copy from here and we paste it, right? So now we have done the first 4 steps. We have imported the libraries, we've imported a data set, split it into training set and test set, and did the feature scaling. So now our machine learning system knows which 2 data are more similar to each other so that it can classify it better. So now we will train the logistic regression model on the training set. And let's begin coding from here. So from here only, we will be coding something new. And I hope that I'm sharing the right screen. All right, so we have splitted this training set and test set. We have also feature scaled our data. Now we are doing the logistic regression, right? So first, what we'll do is what we do all the time. So we'll go to scikit-learn library and we'll see how scikit-learn does logistic regression. So in scikit-learn library, what we will do is we will search for this logistic regression, so that we are not remembering everything, but we are using this library to code every time. So I go to this logistic regression file and I see that it is in the linear model. Okay, so from scikit-learn.linear model, I will import this logistic regression, right? And it has some arguments. We'll see if we need to put in arguments or not. So if we scroll down, we will see how to code this, and we can code this like here. So from scikit-learn.linear model, we import this logistic regression, we make a object of this logistic regression, and we perform this logistic regression on our data, right? So let's do that. So here we actually start to code new file, right? So from scikit-learn, what we will do is linear model. So I just go back, linear model is that. Linear model, we will import this logistic regression, right? So from scikit-learn.linear model, we import this logistic regression class. So I hope that it's all fine. And then we will make a logistic regression. So we'll call that regressor, and we will inherit this logistic regression class, right? And we will just keep one thing here, which is the random state, and that's just so that my data and your data is same. So regressor, I created this logistic regression class, and I random state is 0 for this, right? And then so let's not call this regressor because that would be not so let's call it classifier, because we are not doing regression, we are classifying actually whether the customer will buy the car or not, right? So let's call it classifier, and let's fit and transform our data, which is sorry, fit, not transform, just fit our data on X train and Y train, right? So I'm basically using this classifier to fit on X train and Y train. Okay. So same steps, just like regression, but instead of linear regression, we are doing logistic regression, and we are making a classifier for this logistic regression, and with a random state of 0, and I am fitting this on X train and Y train, right? So there is a question in the chat which is very interesting. Why X train and Y train? Why not X train and X test? So we basically are mapping my X to Y, right? I'm not mapping X to X. How can I map X to X? So I'm finding trends in X and mapping it to Y. So this classifier will find the trends from X and map it to Y. That's why it is taking, right, the trends which it will map, and it will fit that into that sigmoid curve. So that sigmoid curve is a relation between X and Y. It's not a relation between X and X, right? So we're fitting this. So we are basically, with this fit method, basically we are designing this sigmoid function, which is working on X and it is mapping that on Y, right? Okay. And so Tushar is asking, what is the difference between fit and fit transform? So fit class is basically finding the trends, and transform will actually change the values of this output of X train and Y train. We are not transforming it. We are just finding the fit line. Okay, so we are just finding the best fit of the logistic regression. If we transform it, we transform all of our data according to whatever the fit is, right? So that's the difference. Okay, so if you have coded the logistic regression, please type done and yes, so that we can move ahead to predict a new result. Okay, thank you so much, those who have done and coded this. Shubham, Avani, Inshras, Dushyant, Jayesh, thank you so much. Archana, Pooja, Ritika. All right, thank you so much for keeping the pace of this session so that we can finish this session on time. So let's predict a new result. So now we have this classifier, which we call classifier, right? So if we can predict whether the person will buy the car or not, let's see if we can predict that, right? So what we'll do is, those who are experiencing any error, I will take the error resolution by 6 p.m. only. Okay, before that I will not take. Ayush is asking why random state 0. So random state can be anything, but it has to be similar. Like if my random state is 0, then yours should also be 0. If my random state is 1, then yours should also be 1. So why it is doing that? Because it is taking randomly the data from the data set that it is there, and it is classifying that. So if my random state and your random state is 0, then our logistic regressor will look similar. Otherwise, it might look a little different. It won't hamper the productivity or the accuracy of that model, but it will keep our graphs similar. All right, so that's why random state 0. We can keep it anything. We can keep it 1, 2, 3, 4, as far as that your random state and my random state is same, right? Okay, so let's predict a new result. Let's say if a customer is of age 40 and he has a salary of 40,000. So whether that person will buy that car or not. This is what we have been looking forward, right? The company needs that only. So Harsh is saying that he missed feature scaling. So feature scaling is where you, which you did in data pre-processing. You go to data pre-processing template. We have already done that in second masterclass. Go to feature scaling, copy that code from there and paste it here. So you will be able to achieve feature scaling here, right? Okay, so we predict a new result. That means the car company is asking you to predict whether a customer who has an age of 40 and salary of 40,000, whether that company will, whether that person will buy the car or not. Okay, so let's print that, print, and we will use this classifier and predict function to predict this. But inside also we need to do the scaling, right? So standard scaler. So you need to do the scaling because I cannot use the actual values, but scaled values. So sc dot fit transform, not fit. I'm not fitting it. I'm just transforming it. I already have fitted the data. Sc dot transform and a double array. That means that two-dimensional array of a person whose age is 40 and salary 40,000. Okay. This I am printing the output of this classifier for a person whose salary is 40 and whose salary is 40,000 and age 40, and I'm transforming it because I need it to be normalized, right? Because the logistic regression is trained on normalized data, right? So that's why I transformed it inside. So I'm predicting whether the person will buy the car or not. Okay. So let's see if the prediction is, so it says that the person will not buy a car. It says that the person has 0 chances, or the person will not buy a car. So let's increase the salary a little bit. So let's say 1,40,000, and it says that the person will now buy the car. So let's decrease the age, or let's say increase the age to 68, and let's see what is the prediction. The person will buy the car, and let's increase the age to 100, and it says the person will buy the car. Okay, so if a person has this much of money, the person will buy the car, right? So if I change the value to 32 and salary to, let's say, change the value to 22 and salary is 40,000, the person is not buying a car. Okay, so this way we can create a system where the person is buying a car or not by understanding and learning from the data. Now let's see whether this model is perfect or not, right? It is working fine. It is working fine. But how do I know whether it is predicting right or not, right? So if you have reached here where you can predict a new result, just type done or yes in the chat box. Right? Thank you so much. Those who are having the error SC is not defined, they did not have done feature scaling. So please do feature scaling first. Their SC will be defined. Okay. All right. Thank you so much. Those who have already done. So predicting a new result is just this. Keep SC small, and you need to do feature scaling first. Right. So you have made a standard scaler and you are transforming the new data that you have with that standard scalar only, right? Okay, so keep in mind the boxes here, like the brackets. So it should be two brackets. You should be closing two brackets. So that blue bracket should be closing here, and that pink bracket should be closing here, and that yellow bracket should be closing here, right? So please mention this. Now, okay, so Abhinav is having an error like this where he is printing the value, and because you have not transformed this earlier, so you have to run the code of sc.transform transform earlier. Okay, so then only it will be predicting, or you might be mapping xtrain to xtrain itself. So here you need to classifier dot fit xtrain to ytrain, then only your data will be fit from xtrain to ytrain. Okay. X has two features, but standard scalar is expecting one feature as input. So Premiraj is asking me this question. So X has two features. X has standard scalar is expecting one feature as input. It should not be like that. I think you are using capital X in the example, and we are using small x. So let's just check once whether your code is fine or not. If you still are experiencing error, we will address it by the end of the class. Okay. So let's predict the test results and see how our results map. Okay. So let's predict the test results and see how our errors map. So let's see whether how much is the difference between predicted output and the actual output. Okay, so we'll predict the test set results, and we will side by side compare it with the predicted results. Okay, so for that, we will use yesterday's code where we were predicting, where we were printing it side by side. So we'll go to multiple linear regression. So in our Google Colab, we will search for multiple linear regression. Just type multiple. I think your file will be there. And you go to multiple linear regression. And from multiple linear regression, where we were printing those values side by side, we will choose that field. Okay, so predicting the value one. So this. Now, we need to just copy it from here. And we need to paste it in our code. Okay, so we need to just remove this second line. We are not having any precision because our y values are just 0 and 1. And instead of regressor, we will use classifier. Okay, so I am predicting these y predict values, which is classifier.predict, and I am concatenating these two arrays in columns. Okay, so if I execute this, now I have these values like zeros and ones. So I can compare now so for y, so for most of the values, I have like 0, 0, and like it is predicting fine. So I can see there are some values where it is not predicting the way it should predict, like here. Okay, so it predicted 0, but the person is actually buying a car, right? And somewhere here where it is predicting that the customer will not buy a car, but customer actually buys a car. Here also the same, and here also the same, right? Let's check whether here also the same. So there are some errors in the predicted output and the actual output, and this will happen because our system will never be accurate. So if you have identified your test set results, if you have predicted them and printed them side by side, please type done or yes in the chat box so that we can move ahead. Thank you, Shubham, Pooja. Thank you, Lokesh, Dhrui, Krisi. Thank you so much, Ruchita, Ashwin. Ashwin has not done, so you will have to do it quickly. So the process is you have to go to multiple linear regression. So in your Google Drives, type multiple. In your multiple linear regression template, you copy where we were predicting the test set results. So here you copy it from there, and you just need to change two things. Instead of regressor, you are using classifier, and the second line is not required because we don't have any precision because we are only predicting zeros and ones, right? For Ashwin, the result is different because your mapping should be right. So your mapping should be X train to Y train. Okay. So please check whether you are fitting X train to Y train only. If you are, or also you check what your X and Y are. So if you have put this semicolon here, okay, so that will always create an error. So you need to just keep it -1. All right. So Ashwin, if you can check whether your X and Y are fine and you have transformed X train to Y train only, then your error will be. All right. So now let's make a confusion matrix, and confusion matrix will determine how much accurate my model is. Okay. So Utkarsh is asking how explain to predict new result. I already explained it, but I will do it one more time. So what we are doing is we are predicting for any new customer. So a customer, suppose of age 22 and of salary this, right? But we need to transform that because we have normalized this here. So we have done feature scaling here. So we need to feature scale it here also. So we feature scale 22, feature scale 40,000, and then we predict it using this classifier that we made, and we print that result. So if it is 0, the customer will not buy a car. If it is 1, the customer will buy a car, right? Let's move quickly to make the confusion matrix. And confusion matrix will determine whether my model is working fine or not. What is a confusion matrix? So let me just search for a confusion matrix on Google. And if I go to image, then basically a confusion matrix looks like this. Okay, for any results, we will try to find the true positive, false positive, true negative, and false negative. That means that so this is predicted output. Here we will keep predicted output, and here we will keep the actual output. So if the predicted output and actual output is right, that means that the model predicted whether the person will buy a car, and the actual output was also the person buys a car. So it will be the true positive. But if the model predicted that the customer will not buy a car, and if the model predicted that the customer will buy a car and the customer does not buy a car in reality, then that will be labeled as false positive, right? If the model predicts that the customer will not buy a car and the customer actually buys a car, then that will be a false negative. If the model predicts that the customer does not buy a car and the customer actually does not buy a car, so that will be a true negative, right? So we will make this confusion matrix, and we will see how many times our model is actually predicting right. That means that for every customer which buys a car, it predicts that the customer will buy a car. And for every customer which does not buy a car, it predicts that the customer does not buy a car. So we will see how many times our model is working nice or fine. Okay, so that will move us to this part. Sorry, I'm sharing the wrong screen. So that will move us to this part of our machine learning journey, where we are evaluating our model. So we are basically calculating this performance metrics, whether our model is working fine or not. Okay. Please be mindful that I am not solving errors right now. I will solve all the errors after 6 o'clock because I have 3 models to cover, and that will not be the sufficient time if I solve each one's error right now. Okay, so please be patient till 6 o'clock to solve the error. I will share again the code that we were doing. So we are going to define this confusion matrix for our output mapping, this mapping. So we will try to find out how many times our uh, model predicted right. That means for customer purchasing, it is actually purchasing the car, or customer not purchasing, it is actually not purchasing the car. Okay, so these two values we are interested in. These two values will be errors. So false positive, false negative are always errors. So let's see how efficient our system is. So let's make a confusion matrix. And for that, we will again use scikit-learn library. We will search confusion matrix. And we will see that here is the confusion matrix display, or we are not we are not interested with displaying it in a plot. We just need the confusion matrix. Okay. So we can also display it like this. The confusion matrix, it will be visualized like this, but that is for you as a homework. So you go to scikit-learn library, see how your confusion matrix is, and you can also use this code to display your confusion matrix. So right now I'm not going to explain this big code to you, but we are going to make this small confusion matrix which looks like this. All right. Just share you the right screen. Okay, so let's make the confusion matrix. And for that, what we will do is we will import this from scikit-learn dot. Where do I import confusion matrix from? I'll just check the code. Matrix, M-E-T-R-I-C-S. So I will use this matrix function. So from scikit-learn dot M-E-T-R-I-C-S, I will import this confusion matrix. That's it, C-O-N-F-U-S-I-O-N and M-A-T-R-I-X. Okay, so confusion matrix, all small, C-O-N-F-U-S-I-N, confusion matrix. And the other one I need is accuracy score. Okay, so accuracy score. So confusion matrix and accuracy score, these two libraries I will import from this. Okay, so you can also import this confusion matrix visualizing, but this is for you as a homework. So you study scikit-learn library. How can you visualize your confusion matrix? How can you actually achieve this kind of graph? So actually achieve this kind of like graph. Okay. But right now what we will be achieving is the table like this. Okay. Now what we need is we will make a confusion matrix and CM, let's call it, and it will inherit this confusion matrix class. And what we are making confusion matrix of? Y predicted values and Y test values, right? Actually, it should be Y test first, the actual output first, and Y predict later. And this is the confusion matrix, and I print this confusion matrix. So I print this CM, right? Let's see how it prints. All right, so I have this confusion matrix now. So for 57 times, my output was predicted false, true positive. That means that out of all the data for 57 times, it predicted that the result was correct. And also out of 17 times, it predicted that my output was true negative. That means that true positive and true negative, this is my accuracy score. Only 6 times, 5 plus 1 is 6. 6 times it's predicted wrong. Okay, so in this table, only 6 times my data was wrongly predicted. Okay, I can also check this using accuracy score. Okay, so let's check our accuracy score here. So for accuracy score, I just need to call this accuracy score class, and let's put Y test and Y predict, and it will output the accuracy score. So the accuracy score in my case is 0.925. That means that 92% times my model predicts right. Okay, so that's fairly good enough that my model is predicting right for 92% of times, and that's what I am interested in. And I'm very happy with this model. So let's see if we can increase the accuracy to 95% with other algorithms, but we will see if we will require that or not. Okay. So if you have made the confusion matrix and if you have got the accuracy score, please type done or yes. For some people, it will be different. For Inshra, it is 57 and 18 and 4 and 1. That depends on how your data has been categorized by the model. Okay. So for Javed Malik, his score is 0.89. So make sure that when we are actually transforming this here, sorry, I just not sharing. So that depends on this random state. So if your random state is 0 and my random state is also 0, so it will be splitting it uniformly, and your data and my data will be equal. So if your random state is 0 here also and here also, then our data will be similar and our accuracy score will also be similar. Otherwise, our accuracy score might differ, but it will not differ too much. Okay, so for someone, the score will be 0.9. For someone, the score would be 87%. For someone, it should be 88%. That depends on how their data is allocated. All right. Some model scale is 0.91. Okay, so if you have kept the random state as 0, so your accuracy score and my accuracy score will always match. Yeah, so Daksh has same 0.925. All right, so let's move ahead with visualizing the training set results. And now by visualizing the training set results, that means that we are visualizing the decision boundary. But to visualize that, I will not explain the visualization code because that will be very hard to explain in this less time that I have. So what I have done is you go back to the link that I'm sharing and you will go back to Avani is asking, please explain confusion matrix. I have already explained it, but if you want me to explain it one more time, I will explain it very quickly. So confusion matrix is a matrix. That means it is a graph of actual output and predicted output. So if my actual output is same as predicted output, that means that my actual output was 1. That means the customer bought the car. And my predicted output was also 1. That means that the customer will buy a car. Then that will be true positive. That means that is the desired result, right? I need my model to predict correctly every time. But if my model predicts that the customer will buy a car, but the customer actually did not buy the car, that will be false positive, right? That means I'm getting a positive where it should be negative. And if the model is like this, that the customer did not buy a car, but the customer actually buy a car, so that will be false negative. That means that the model is predicting that the customer will not buy a car, but the customer actually bought a car. And if the customer did not buy a car, and if the customer, the predicted outcome was that customer will not buy a car, and the customer actually did not buy the car, then that would be a true negative, right? So we are interested in these values, the true positive and true negative, to find out how effective my model is. And false positive and false negative, I will minimize as much as I can. All right. On the basis of this only, I will check my accuracy score. Now, to visualize this, I will share the link one more time in your Zoom chat. So I will just go back to the link where it was there, and from the link you have to go to this code file. Okay, so I'm sharing it again on the chat, meeting group chat. So from this link which I have pasted here, you go to this code file. Okay, this code file here. So you double click on this code file, and in this code file you copy this code here. Okay, so why we are copying this? Because this basically creates a decision boundary. You don't need that. Maybe in your life you will never plot a chart like this, but just for seeing how a decision boundary looks like, we will do this. I kind of like made this chart with the help of ChatGPT. So I asked ChatGPT to create a code for me so that I can visualize the decision boundary, and it created a code like this to me. So I will just copy this code. I will need to change some things. That means that the ChatGPT has made all of these capital for me. So X1, I think it's fine. Nothing is wrong in this. So I'll just plot this. Yeah, capital X train is not defined. So I will just change that where the capital X train is there, right? So the error will be only when we have changed the X train. I'll just see where the X train is, and it is here. So I will just change it to small X train. Okay. And it will plot. CL is not defined. That means that where is it? Yeah, CL is not the classifier. Our classifier is named as classifier, right? So you need to change two values, CL to classifier and X train to X train. Okay. So I changed capital X and classifier. So ChatGPT wrote it as CL. So do not trust ChatGPT code all the time. You need to trust your coding skills so that you can debug ChatGPT's code, right? So we debugged it by changing our capital X to X, and we can see this beautiful, beautiful graph here. So here is the decision boundary, and these are actually the customers who will buy the car, and these are actually the customer who will not buy the car. Okay. If you are still experiencing error, then you need to change this CL to classifier. Okay. CLASSIFIER. Nothing else you have to change. Okay. So one thing is X to X train. Name should be CLASSIR. The ChatGPT will have CL as the classifier. Okay. So let me know if you have got a graph, beautiful graph like this. Okay, so please paste done or yes if you have got a beautiful graph. So the graph tells me that this is decision boundary. This line is the decision boundary. Here are the predicted output for the values 1, and here are the predicted output for the values 0. And all these outliers, these are the points which the data was not able to cover because these do not have any clear decision boundary. So let's see if we can have a different decision boundary than this. Okay. Sushant is having an error where he's not getting any graph. Maybe because I will need to check what the code is. Maybe because you copied wrong code, so you need to copy this above code which is in black. Okay, so that's why I made it black and white. So for first you need to copy the code which is in black. So basically what it is doing, it is creating a mesh grid, and from that mesh grid it is creating the decision boundary, and it is doing this inverse transform on X train and Y train, and it is actually predicting that boundary to us. Okay. Those who are getting a different graph, they need to check whether they are Suraj is still getting an error that SC is not defined. You need to define SC here. Okay, so if you have defined SC in capital in feature scaling here, then that would be giving an error. Okay. Now we need to also plot for test set. So for test set results, you need to copy the white code, which is there, code in white, and you need to just change the same values again. So copy the code in white and copy the whole code, okay, not the half code, and you go and paste it here. And instead of X test, you make small X test, and instead of CL classifier, you type in the full name. Okay, and you press Shift plus Enter, and you will see that this will be for the visualizing the X test results. Okay, so it will create the decision boundary for the X test results. So if you are experiencing any error, you can copy the code again. Yeah, maybe there was some code also there, but that was only the Y label. Okay, so I just missed the Y label. So somebody said that I did not copy the whole code. There is some other code also. So that was just the Y label and the legend and the show method. So that will not hamper anything that is there in the graph. But let me just do that again. Okay, so that will also give me a legend like this. So this was not there. Also, the Y label was not there. That was the only thing that was missing, right? So I can see the decision boundary. Akshay is saying that I defined SC as SC underscore X. Yeah, so you can change SC as a SC underscore X wherever there is X. Okay, here also SC. So you change it according to what you defined. So debugging the code is according to you. How you have defined your parameters, I don't know. So that's why you need to debug it on your own. Okay. Now you will see the decision boundary of the test set results, and I can see that only one output which was predicted as a false positive is here, and there are 1, 2, 3, 4, 5 false negatives. Okay, so let's see if we can if we can improve our accuracy and if we can improve our decision boundary by using other algorithms. Okay, so let's move into the second algorithm. So if you have achieved both the graphs, and if you have done everything that is there in logistic regression, please type done and yes, so that we can move to the next algorithm. All right, Devansh, Inshra, everyone has done, even those who have who are getting errors. Thank you so much. Those who are getting errors, I will address this in the next after 6. Okay, so Kriti, I will address your graph after 6. Okay, let's move on to the second algorithm, which is k nearest neighbors. All right. So now to improve our accuracy, we will use another algorithm. We can use a simpler algorithm where we are not even required to do complex mathematical things for classification. Okay, and one simple algorithm is called k nearest neighbors. So suppose we have two data sets, two groups, two category of any data set. So suppose let's say that these were the people who bought the car. It's 1. Okay, and these are the people who did not buy the car. Okay, 0. So we stick to our example. It can be anything. So suppose we have two groups, whether here the people are not buying the car, and here the people are buying the car. Okay, there are two categories. The blue ones buy the car, and the orange ones, they do not buy the car. Now I need to find. So if I have a person who is a new person, so I am predicting for that person. So that person is here, and how to determine if that person will buy the car or not. Okay, so how to classify this as into this category or this category, right? This is what we were doing, right? We were classifying people. We are finding a decision boundary, and we were classifying people whether they belong to which category, right? I think I'm not sharing the wrong. Yes. Sorry. Thank you so much. Those who told me that I'm sharing the wrong screen. All right. So I will have to do it from start now. Okay. So we have two type of categories. Suppose. Okay. So this is the graph, and these people, those who are in blue, they buy the car, and these people, those who are in orange, they don't buy a car. Okay. So suppose they are 0 and they are 1. Okay. Now I need to find, so let there be a new person, okay, on the graph. So I need to find whether that person belongs to this category or whether that person belongs to this category, right? This is what classification is, right? Whether the person will not buy a car or whether the person will buy a car. So to find where that new person for which I'm making this prediction system will buy the car. I need to understand. Wait, my slide is not changed. Somebody saying it is changed now. So I need to classify this to which category, right? So to do that, I need to understand what is my decision boundary, right? So how to classify whether that person will buy the car or not. Okay. So what in k nearest neighbor, which is a very simple algorithm, what we do is we take a number k. Okay, so we take k as a number. So for okay, so we take k as a number, any random number. Okay, so let's say k equal to 5. That is a hyperparameter which we will tune. So we say that there are we take k as 5. Okay. Now what we do is we calculate the distance of these 5 points, any 5 points, which are the least distant to this point. Okay. Suppose a customer whom we are predicting is this point, and we take this k as 5. So for 5 points, we will find out the least distant. So we will do this Euclidean distance. Euclidean distance, as you all know, is under root of x2 minus x1 square. So this is the Cartesian distance between 2 points, minus x1 square plus y2 minus y1 square, right? So y2 minus y1 square. So this is the Euclidean distance. So you calculate Euclidean distance from these 5 points. So and you categorize them the nearest 5 points. So this is nearest 5 point, this is nearest, this is also near, this is also near, and this is also near. So we will select these k numbers. So we select these 5 k's on the base of the Euclidean distance. And then what we will do is we will count in which category how many points are nearer. So in this category, there are 3 points which are near. In this category, there are 2 points which are near. Okay. So according to the distance, we chose 5 points to be evaluated upon. And in this category, 3 points are nearer. In this category, 2 points are nearer. So what I will do is I will categorize this data point into the category which has more neighbors near. Okay, so k nearest neighbor, that means that how many neighbors are near to this point, in which category. I will categorize it to that. So I will say that this person will not buy a car. Okay, understood? I will explain it one more time. So what we will do is we will choose any random number k. Let's say 5. 5 is the best number because it's an odd number and it will give you the perfect boundary. And there are 2 classification there. So if we are predicting it for any new data point, whether it should lie on this category or that category. So what we will do is we will take the Euclidean distance, which is under root of x2 minus x1 square plus y2 minus y1 square, and we see where are the most neighbors. So in this category, there are 3 neighbors. In this category, there are 2 neighbors. So I will safely say that this point belongs to this category. Okay, it is closer to this data set. So basically, we are trying to find where this point is closer to, which category this point is closer to, and whatever category this point will be closer to, it will be classified there. So if a point is here, let's say, so all the 5 neighbors will be from this category only, right? So 3, 4, 5, because the distance between this and this category will be more. So I will classify this as this group. And if a point lies here, then all the 5 neighbors will be from this category. It will be classified as this, right? If a point lies here, again, like 1, 2, 3, 3 neighbors will be from this category, maybe 1 neighbor from this category, 1 neighbor from this category. So there will be 4 and there will be only 1 here. So this point will be classified in this category. So this is the simple algorithm. This is a visualization of the algorithm, which is k nearest neighbors. All right. So let's code that and see how the decision boundary changes when we use k nearest neighbors method. Okay. So we will go back to our coding again. I'll share the code again. The data set is similar, the same data set. And Devansh is asking, k will always be odd. So it is good to take it odd because that will give us the proper decision. But even if you take it even, for even if there is an even distance between 2 points, then that will not be able to classify whether it should go to some point or some. So if it will be equidistant to 2 points, taking k will not work as 2, right? So need to be odd to make a clear decision, right? So let's code it. I will share the code set again, and the code set is in the chat box. Data set is same. So you will use the same data set. Already have that. I think that I'm pasting the code in the right chat box. The code is here. And data set is same. So you go to this file again, and you need to code this k nearest neighbor. Okay, so you need to use this template, k nearest neighbors, and download this template. Okay. All right, so we already know how to code now because we have been coding for long. So we will start with importing the libraries. So what we will do is the code that we just wrote, the logistic regression one, we'll copy this from there. And first of all, make a copy of this. Save a copy in Drive so that you are renaming it to your name. And instead of copy of template, write Amit, your name, and import the libraries. So code, importing the libraries, and just run the cell. So you import the libraries, you run the cell, and you import the data, which is here. So car purchase data again. And here also the same code. So you change that, import the data set. Again, the same data set is there. So no need to be changing anything. So we copy and paste it here, and we run this cell also. It will give me an error because I have not renamed it. I will rename this file as car purchase data.csv. Okay. Now let me rename it again. Okay. Now it works. Again, splitting the data set into training set and test set is still same. So I'll go back to my code. I will split this data set into training and test set, and I run this. Again, the next step is feature scaling. I will code this again because I have already done that, and I copy this from here and I paste it here, right? Feature scaling also I will do. Okay, now feature scaling does. The only thing we will require new is the training the KNN model, right? And I code this from here. Yeah, I hope that I'm sharing the right screen so that I can go to the scikit-learn module, right? So basically I will go to scikit-learn, and from scikit-learn I will train the model on KNN. So I will go to scikit-learn, and here it is open again only. So I will type K nearest, NEAREST, and just press enter. And okay, so K neighbors, NEIGHBORS. Okay, K neighbors. And I see that there is this K neighbors classifier, right? So K neighbors classifier is the classifier name. And where can I import it from? I can import it from neighbors class. Okay, so K neighbors classifier, I need to import it from neighbors class. So I can see that here, this K neighbors classifier from neighbors class. So I will copy this from here and just type it from sklearn.neighbors import K classifier, K neighbors classifier, and I make a object which is classifier again, and it will take it will be an object of K neighbors classifier. And in the bracket, what I will do is I will specify these parameters. So I go to scikit-learn and I see what I need to specify. So I need to specify how much neighbors should be there, right? The K value. So, and so I need to classify this neighbors, and 5, and the metric is minimum of so minimum distance, so Minkowski distance. So Minkowski distance is actually the Euclidean distance. So if you type in Minkowski distance, so it is basically a generalization of both Euclidean and Manhattan distance. So both the distance it will take. So Euclidean distance also and Manhattan distance also, whichever it will be the smartest, it will take that. So we'll choose this Minkowski distance, and we'll specify this T. That means that there are two categories. So the categories are two. So two categories are there. I need to find 5 neighbors with this metric of Minkowski. Okay. And then I will fit this classifier dot fit it to xtrain, and I run this. Sorry, I think Minkowski is Minkowski. So Minkowski. Okay, so I need to specify only 3 parameters. One, the hyperparameter K, which is 5 nearest neighbors. Metric is Minkowski, that means the minimum Manhattan distance as well as the Euclidean distance. And there are 2 categories. That's why I'm specifying 2 here. Okay. So let's predict a new result. We have done this in logistic regression where we were predicting a new result. So let's predict the same result that we predicted here. And if we predict a new result here, then let's see if it gives 0 or not. Okay. So it says that it is 0. That means that it is working fine. Like my both models are working fine. So I can see here I have made this K nearest neighbor classifier. Okay. So please do this first. People are asking, can I share the Google Colab K nearest neighbors link? So I think the template is here. I can share the link again to anyone, and in the chat now. Okay. So anyone who needs the template, it is there. Nearest neighbors object has no attribute. So you are using wrong wrong predictor. So it should be K neighbors classifier, not the nearest neighbor. Okay. So from scikit-learn, you need to also understand what to import. So you're importing this classifier, not the nearest neighbors. So what you did is you copied this. Okay. So Tushar, you did not have to copy nearest neighbors. You had to copy the classifier. You are making a classifier, not just calculating the nearest neighbors. Okay. There will be a prediction difference in both the codes. So for logistic and K nearest neighbor, the prediction difference will be there. Okay. Let's predict the test set results and see how our model is behaving. Nothing will change. We'll just copy the code from logistic regression and predict the test set results, which will look like this. Okay. And we can see that for most of the values, it is predicting correctly. Let's also print and make the confusion matrix and see if anything changes from the previous algorithm. Okay, so we copy this from here, the confusion matrix, and we paste it here. And we see that now my error is less. Previously, it was here, if I see, I have 6 errors. Now in K nearest neighbors, my error is just 4. If I can just check the accuracy score, how much is the accuracy score? I will just go back to my accuracy score and copy it from there. And I paste it here and I run. So I check that my accuracy score has increased from 0.925 to 0.95. All right. So accuracy score has increased and my confusion matrix has also increased. So I can see that the K nearest neighbor algorithm is better in classifying rather than the logistic regression, right? So I will just this code you need to change. Madhu has got 88 to 93, which is a remarkable change, so that your model will work nice now. Okay, so let's visualize the training set results. Nothing what we have to do is, what we need to do is we need to copy the code. I've already given you the code. Again, go to the code here and copy this code where we were visualizing. Copy this and go back to visualizing the training set. And doing that is, yes, here. So you change this X to small x and this CL to classifier. Okay, and you visualize this. It will take some time because it is a time-taking process, because it will make, it is not a straight line but a different curve. So I will just show how it looks like. A lot of people have got 95% accuracy. Let's see how the graph looks like. It will take some time to connected to runtime environment, and more RAM and more uh, resources will be required for this. So that's why, oh, sorry, should I just delete that? Just in process of closing the chat, I deleted it. So I'm really sorry for that. Let me just do it again. If somebody has been able to plot or visualize the graph, can you just, yeah, so my RAM has been, so I don't have the required RAM now because I think, allocated all the RAM to this. Okay. So maybe if I run it from start. So for those having errors, just run it from start. So run all. And let's just check if the prediction results are coming. So because it will plot a very different graph. So I will just show you if I have a plotted graph with me. All right. Even after restarting the kernel, the error is still there. Okay. So maybe when I did it with more RAM allotted, so I will show you when I did it in other tab. Okay. So when I run it, this is what I got. So when I allocated more RAM to my project, so I can allocate using Google Colab. So I got this graph. Okay, so you can see the decision boundary like this. So what you need to do is in your runtime environment, you need to allocate more RAM. So how to do that is from here, you select change view resources and uh, manage sessions. I have already used 1.19 GB of RAM, right? Maybe I can allot more resources to it by changing it to T4 GPU. Okay. So you change your runtime environment to T4 GPU. So it will allocate more RAM and it will be a four uh, like more core processor, or maybe you can just use a tensor processing unit. So let me use a tensor processing unit. Okay, so you go here and you change runtime type to a tensor processing unit and save it. Okay, and let me run it using a tensor processing unit. All right. Okay, so it has taken my data also out. Let me just put the data and rename it. Now I run all. Okay, so I have changed my environment. So my data was also taken from this and I'm running. I think I have not upgraded it. Maybe just a T4 GPU will do. Not the tensor processing unit. You need maybe subscription for that. Previously it was free. I don't know how Google has changed it. So let me just open this. The last time I coded this with other batch, it was working. Google has changed its processing maybe. Let me see if I can do it with T4 GPU. Yes, I can do it with T4 GPU. So let me run everything. Okay. So how I changed my environment, some people are asking. So you go here and you change runtime type. Okay, and you change it to T4 GPU. So if I choose T4 GPU, then I think I should get it. Okay, not sharing the right screen. Someone is saying. So basically I changed it to T4 GPU and I think I'm sharing the right screen now. But again, it is crashing. Okay. Again, it is crashing. No worries. Last time I did it in Mac, it worked. I don't know. Right now I'm using a Windows laptop and I don't have the RAM. If it is working for someone, please let me know. Otherwise, maybe if we work independently, maybe it is taking more resources because we all are working on the same file. Maybe if we work independently, it will work. But that's not actually important. What is important is how it looks like. Okay. So this you can work independently. Yeah, it's not working for anyone. So maybe if we work independently, like not in a group, because right now 300, 400 people are like doing it at the same time. Google might not be able to handle that kind of uh, sessions for free. Okay, it handles it for professionally. So if we pay, we will get it. But last time I did, I got a decision boundary like this. Okay. It will work in Jupyter if you do it. Okay. So Himanshu is asking, yeah, you can work in. So this is a decision boundary. So decision boundary changed from linear, it changed to sometimes somewhat it looks like this. Okay. And decision boundary in the test set also is like this. So we can see that the decision boundary has changed. That's why our accuracy has also changed, right? So my accuracy has come to 95%. All right. So that's what we are looking for. Okay, so let's improve our accuracy more and let's improve our confusion matrix more with one more algorithm, and which is the last algorithm, which is the support vector machines. Right. So this is the last algorithm we will be covering in supervised learning, and we are already running behind the schedule. This is the last masterclass, and we will not be able to cover that. Right. Okay. So last support vector machines, you might be able to use this in your final projects. That's why I need to cover this. So let's do this. Okay. So similar problem. We have a data set where we have two categories, right? So one category is this and one category is this. So we need to find the decision boundary, how we can divide these two categories. So one decision boundary can be like this, a vertical line, which divides this customer who bought the car and the customer who did not buy a car, right? This is one decision boundary that we can make. Another decision boundary can be a horizontal boundary, right? The customers above this, maybe I'm not sharing the right screen. No, I'm sharing the right screen. The customer above this will not buy a car and the customer below this will buy a car, right? So this is also a decision boundary. Maybe a decision boundary can also look like this, right? A vertical, a sloped line, or like this, or many sloped lines. How do we know which decision boundary should we rely on? So what the algorithm is called is support vector machines, and it finds the perfect decision boundary. So we are in search of the perfect decision boundary that will divide these two data sets from each other, so that at any point we keep the data point. So any new data point is here. So on the basis of the decision boundary, we can tell whether it should lie in 0 or whether it should lie on 1, right? So basically we are in search of a decision boundary. So how to find that perfect decision boundary, whether it should be vertical, horizontal, slanted, and slanted to what extent, right? So what we do is in support vector machines, what we do is we find an algorithm. So we take these two points. So these two data points, which are at the boundary of each data set. So in this data set, sorry, each category, in this category and in this category, these 2 points are closest to each other, right? These 2 data points are closest. So in reality, if I say that this is a 2-dimensional graph, so 2-dimensional graph, these points will be called, points. And if I increase the dimensionality, that if I go to 3-dimension or 4-dimension or 5-dimension, these points will change to vectors, right? So these points will be vectors. So these 2 vectors. So now what we are doing is we are basically finding these 2 vectors which find that decision boundary. Okay. And how to do that is we find what we do is we take these 2 vectors and we find a decision boundary so that it has the maximum margin from both the vectors. Okay, so this vector and this decision boundary also has the maximum margin, and this vector and this decision boundary also has the maximum margin. That means that it is equidistant from these 2 vectors. So these 2 vectors actually are the vectors which are at the corner of both decision boundaries, And that's why it is called, these two vectors are called supporting vectors. And we are in finding this decision boundary, which is maximum margin from these two supporting vectors. Okay, there can be many vectors which can be supporting vectors, and we are finding this decision boundary. And in a two-dimensional plane, it will look like a line. In three-dimensional, it will look like a plane, and in multiple dimension, it will look like a hyperplane. So basically, we are finding that hyperplane, which is at maximum margin from these two vectors, which are closest to each other. So what we will do is we will quickly quote that we are at the brink of completing all of our algorithms. So final algorithm will be support vector machine, and in support vector machine, the algorithm is that we are finding this maximum margin from which these two supporting vectors are at the maximum distance. Okay. So let's see if we can improve our graph, improve our accuracy using support vector machines. So what you need to do is you need to again go back to the same code. So let's go back to the same code. I'm sharing this link with you. Meeting group chat. Okay. Okay, so you go to this link again, and you will find the algorithm, which is support vector machine template. Okay, so you go to this support vector machine template, and from there you will copy this template and make a copy and drive. So once you make a copy and drive, you will rename it according to your name, and here just type in your name, and everything is same. So we will quickly do that. That means that importing the libraries, again we will go back to our code, which is this, and logistic regression or any regression that like you can also take the same code as KNN. The code is similar, right? So just import the libraries using the code and run it. Import the data set, which is again similar to the code, and same data set we are using, nothing changing. So we import this data set here, and for that I need to upload the file also, right? So uploading the file, car purchase data, and from here renaming it. Okay, so rename it and run the code again. So I upload the data set. Okay, third is splitting it into training and test set, which we have done again in both of the methods, KNN as well as support vector. And we'll do feature scaling, which is again we have done in KNN, and copy the code from there and paste it here. Okay, the only thing that we will need is to train the support vector machine on the training set. Okay, so please do it here. I will wait for some time. If you have done here, like done the feature scaling, run all the code cells and type in done. All right. So everyone is set. Thank you so much, those who have said done and yes. What we will do is now we will code our support vector machine, right? So we will make a classifier. So we will go back to our favorite library, which is scikit-learn, and support vector classifier. We'll search for SVC, which is support vector classifier, and we'll see that we can import it from SVM library. Okay, so we can see that here, SVM library, we can import this support vector machine. We can see where we can import it here. Okay, from scikit-learn, we import SVC. So we'll change our code. So we'll code it as in, sorry, from sklearn.s support vector machine. This one, import SVC. So this one, all in caps. Okay. And we make a classifier, which is inheriting this support vector classifier. And we'll mention that the kernel is linear. That means that we are doing the linear decision boundary and not the non-linear. So support vector machines can also do linear, non-linear decision boundaries. But right now we will do linear only and random state, so that your output and my output is similar. Okay, random state, which is simple. Okay. So, and after making this classifier, we'll again fit this classifier. Now I believe that you already know what to do. So fit it on X train and Y train, right? And then run this code. So you have this support vector classifier, whose kernel is linear and random state is zero. Okay, so we can change the kernel to non-linear also, and it will work for non-linear data also. Okay. Now we will predict a new result. Everything will be similar. So we'll go back to our code, which was this, predicting a new result. And I copy it from here and I paste it here. Okay. I see that it still is predicting 0. And let's predict the test set results, which will again be similar because we have renamed everything as same. So this is a very good practice where your name, where your nomenclature is always same, so that you can always repeat your code. You don't have to code again and again, right? So I can see that it is working fine for data, but I will have to check the confusion matrix now. We'll again go back to the code where I have this confusion matrix and copy it from here. Code and paste it. So this is my confusion matrix. It is actually not very good. It is predicting that there are 7 outliers, whereas in the last data I had 2. So support vector machine is not that good in this data set. So I will go to check the accuracy score, and my accuracy score is actually 0.91. So in KNN, I had 0.95. In logistic regression, I had 0.92, and in support vector machine is 0.91. So I can safely say that KNN is the best for this type of data. For some other type of data, maybe support vector machine is working fine, right? Let's see if we can visualize the test results, training and test results. So I have this code with me. Same code I will use, and let's see if we can get the graph. I hope that support vector machine does not take up much RAM. So xtrain and classifier.predict, and I'm not sharing the screen. I think, sorry. Okay, so my accuracy score is 0.9125, and my confusion matrix looks like this. And here I'm running this again. Let's see if we can find the graph. Okay, if it is not there, then I will show from the file which I have achieved the graph. I hope that the RAM is, maybe I am opening a lot of other data sets. That's why I need to close everything. I'll just quickly close everything. So I'll close multiple linear regression, every terminal that I have opened so far, so that I can allocate the best RAM to this and hope for the best. All right. Okay. Let's get it. So let it run in the background. Till we run it in the background, some people are asking for the SVM code. So the SVM code is this. So we need to import this SVC library, and we make the classifier. And so everything is similar. We just need to change this, right? Everything is similar, except for the SVC library. So till now, whatever we have done, maybe it is regression, maybe it is multiple linear regression, logistic regression, whatever we have done, we have kept the code same. Okay. So it's visualizing the training set. Let's see if it can do this. Okay, so let's keep it visualizing. I will show you my results when I did it with a greater machine, and I'll show you the visualized results. Let me get to that file. So this is what I got. So SVM training set. And in this, so this is a decision boundary because we chose linear decision boundary. That's why it is like this. And the test set results look like this. Okay. So maybe if I can close everything and just use this on a fresh day, I will be able to achieve like this, because this I got, was able to achieve in Google Colab only. Maybe some 6-7 months ago when I was learning all of this. So I was able to achieve that. But right now we are not able to achieve because of the RAM, right? So let's see if it's right. If it is achieved, then we will do this. Otherwise, we will do it in Jupyter Notebook and see if we can achieve the graph from there. All right. So we are towards the. So basically, we need this only. So we need the confusion matrix and the accuracy score, and then we can select which model is working the best. Okay. And the predicting code is similar to what was for the for everything. Again, I am sharing the screen. Yeah, so predicting, every code is same like the last two models. Anything that is changed here. It's taking a lot of time to train SVM model. Why it is taking a lot of time? Because SVM is a complex algorithm. Logistic regression is the simplest one, so it will take less time. K nearest neighbor again is a complex algorithm. No, K nearest neighbor is a simple algorithm, but the graph that we will plot is complex because the decision boundary will be not linear. Tushar has got the graph, but it's a logistic regression graph. Yeah, so he has got a graph which looks like this. So if I can share my screen. So Tushar has got a graph of SVM which looks like this. So thank you so much, Tushar, for sharing this. And just needed to change the name of the graph. I hope that I also get the graph from SVM, but it's still loading. Okay. Are we taking 22 and 40,000 values only? So we can take any values, Manaswini. Okay, so this is why I have kept it constant, because I need to check whether all of my KNN and all are working fine. Right? Devansh has got the graph in 7 minutes. Yes, so let's see if we can get it. Till then, I move on because we only have 4 minutes left to what your final project will be. Okay, so we have learned so many algorithms now. We have learned linear regression. We have learned how to clean our data, multiple linear regression, logistic regression. Then we moved on to classification, and we moved on with logistic regression, k-nearest neighbors, support vector machines. There are different algorithms also. There are clustering algorithms. There are deep learning algorithms, which I will not be able to cover in this masterclass. But if you're interested to learn, you can go to YouTube, learn it from there. Knowledge is free. Just you need to have the focus uh, and the tenacity, right? So Piyush has also got this graph, which is like this. In 7 minutes, he has got this graph. All right. Thank you so much for sharing your graph. I hope that I also get it. So what you need to do is for your final project, you have to choose out of these 17 SDG goals that United Nations have, and any of this SDG goal, which is Sustainable Development Goal. So say no poverty, zero hunger, good health and well-being, quality education, gender equality, any of the problems, and design a machine learning model to solve the problem. Okay. So how your problems will look like is this. So suppose you choose zero hunger as SDG. So your problem is like a AI solution to predict crop yields and optimize farming practices so that the crop yield is more, produce is more, and hunger is less, right? So you can choose a problem statement like this. So you take your sustainable development goal, which is zero hunger, and you choose a problem statement to look like this. Okay. Or you can choose as SDG, which is good health and well-being. So you are basically making an ML model to predict any disease. Suppose say heart disease on the base of certain parameters, or suppose say tuberculosis, or suppose say like diabetes. So you take the data of sugar level, maybe the medical data, and you analyze whether the person has diabetes or not, or has heart disease or not, or has cancer or not. Okay, so you choose any SDG from this. Yes, I will share not only these PPTs, but I will also share you the problem statement and how you can write your problem statement and how you can choose any sustainable development goal. Okay. Suppose you choose climate action. So you basically are making an AI model to predict how climate is changing by analyzing historical climate data. Suppose you are predicting whether there will be earthquake in next year or not, whether you will have uh, hurricanes or not based on some data, whether it will rain tomorrow or not, so that you can have an effective climate action plan uh, that you are predicting the natural disaster and you are planning for it. So suppose you choose SDG 6, which is clean water and sanitation. So basically you are designing a machine learning model to monitor water quality. So there are different metrics of water quality measurement, like the pH measurement of water, the parts per million dissolved solvents of water, and you can check whether the water is safe for drinking or not. So you can use any machine learning algorithm. So this will require regression to predict what will be the temperature tomorrow or how much will be the rainfall next year. This will require classification whether the water is fit for drinking or not. This will require again regression whether the crop yield would be more according to some parameter. And this is what will require classification whether a person has a disease or not. Okay. A lot of people have got the graph. Congratulations on getting the graph. I hope that I also have got the graph. Yes, I have got the graph, and I have got the graph which has SVM name. So you forgot to change the name. I changed the name here itself. So SVM training set. So I got the graph like this. So it has a clear decision boundary, which is a linear decision boundary. So basically, less RAM is being used for linear decision boundary. More RAM is being used for when the decision boundary was not linear, like KNN, right? Okay, so not to deviate from where we were. So these are our problem statements, and what do you need to submit is first the concept note of your project. So why the problem which you choose. So out of the 17 sustainable goals, you need to select one problem and you need to describe the problem. Why did you choose the problem and the solution to this problem and implementation. Okay. And the data set, what did you use in CSV format? Okay. And the code, basically I need the IPYNB file. If you are able to design a website, or if you are able to design a WhatsApp app, or if you are able to uh, uh, put the code in GitHub, then you can just provide the link to your panel, and it should be in the concept note. Okay. So basically these three things you need to provide: the concept note, the data set, and the IPYNB file. That means the code. Okay. And there will be a form which will be shared to you by the CSR Box team, and you can always contact me on my LinkedIn. So this is my LinkedIn ID. So if you have any queries, any doubts, please send me a request. I will connect it to you there, and you can ask me any doubt anytime, and I will be ready to solve your problems on LinkedIn. Okay. So what is concept note? So concept note is basically a document. I will share, the CSR Box team will share you a demo concept note, and you can see how the concept note looks like, and you can design the same. So I will show you one which I have in my downloads folder. Let me just go back to the screen. I hope that I am sharing the right screen right now. So go to the downloads folder, and I will show you the concept. So concept. I don't problem statement. So this is how where the problem statements are, and I will share you this file, like what are SDG goals, what do you need to design, what do you need to make, and I will also share you the concept note, how to find this. I think I have not saved it as concept note, but maybe project. Yes. So this is how it will look like. It will be, it has an introduction to the problem, then what are the techniques that you used, and what is the data that you used. Everything about your project will be there, and conclusion, why did you make this project, what is the conclusion of this project, what references did you use to make this project. So this is how a file will look like. This is a complete research paper. You don't need to provide me a research paper like this, but you just need to provide me the file which has all these things, like why did you choose the problem, what is the problem, and how will you solve that problem, and what will be the impact of solving this problem. Okay. All right. Connect to me on LinkedIn anytime. This is my LinkedIn ID. If you have any problems, now we will. There is no word limit guideline. You can make it as extensive as you want. Okay. You have to choose any of the topics. So you can make your own topic. You just need to choose any of these 17 topics and subtopics of these 17 topics, any problem out of these 17 topics, and then you can design your own system like that. Okay. All right. Thank you so much to those who joined me today. And this is the final masterclass of our bootcamp. And I was very honored and lucky to take all of these sessions for you. I hope that you have learned from this masterclass as much as I have learned after teaching you. You have been inspiring. You have been really focused, and I'm really proud that you are taking an ownership of your own learning. Thank you so much, those who joined in on time. Thank you so much. I wish you all the best for your final project, and we'll see that which projects are the good, and we will surely mention them in our annual IBM event, where we host the people who have done excellent in their projects. Okay. In today's attendance, you have to submit the logistic regression on. Okay, so I'm repeating it again. In today's attendance, you have to submit in logistic regression. So you can also use advanced algorithms, which you will learn on your own. So do not be confined with whatever algorithms that I have taught you. Please explore your learning, be open to learning, and there are huge free resources. So if I talk about some of the free resources from which I learn, I'll share you the resources from where I learn. So I learn majorly from YouTube, and because YouTube is free, so I will go to YouTube and I will tell you which channels I learn from. So Stanford Online is one of the channels which I learn from, and it is completely free. You go to Stanford Online, and there you can do any of the courses like machine learning, any of them. Stanford. There are complete courses there. Okay, this is one. And second is I learned from Super Data Science. And this is a podcast that I listen to regularly. And this is the podcast. And here you can get updates of whatever is happening in the world of AI and machine learning. So amazing founders, amazing people come to this podcast and they learn from there. One more podcast that I listen to regularly is uh, This Week in AI. So this last week in AI, and this podcast is also amazing. It tells you everything that you need to learn about AI. So three things that I always refer to. One being the Stanford online classes, uh, whether they are in mathematics, whether they are in CS, whether they are in machine learning, they are amazing and it's free. Okay. All right, so this is it. You can just mark your attendance and I will be open for the next 20 minutes to solve your error. So first error is from Monica. Monica is saying that, can you please share the code for the training set of logistic regression, KNN and SVM? Okay, I will share the code for all three of them. I will be sharing it by mail. The CSR box will send you this. Okay. Attendance sheet will be shared by CSR box team. I request CSR box team to share the attendance with all of the participants today.
Amit, just 1 second before you head into the student queries.
Okay,
I did want to
team,
thank
you can take from here. Okay, so
you.
anyone.
Just wanted to thank you from our end for the wonderful sessions that you've hosted so far. And students, thank you so much for joining in. 4 to 6 is a good, it's a time after college, but you are all a part of the sessions and you've learned a lot from our speakers. So thank you so much, students, for joining in. The attendance link has been shared in the chat box as well as in the WhatsApp groups for those of us watching live. We've also shared the deliverable submission link with you so that you can go through it and know what is expected from you. And our speaker has done a great job in explaining the assignment to us as well. So
I
I
have
hope,
shared you the attendance form for today. Submit logistic regression file only, and
yes.
they have also shared you the deliverables. So the file looks like this. This is the final submission that you have to do, and in this, what you have to do is, sorry, you must be speaking. I had kept it in mute. Sorry, Milan, if I interrupted anything or.
Oh, that's okay, Amit, since you're sharing a screen, great.
Sorry, I just put it on mute so that I can.
That's okay.
All right, so yeah, the screen is this. You have to put in your name, put in your email ID, your contact number. You have to update your learning plan and the project report, which should be in PDF. Data file should be in CSV and IPNB file for the final project code. Also, please tell me how was your experience. I would like to hear 2-3 lines about what we can improve. What did you like in this course? How would you contribute more to the society? I really hope that whatever you are learning from me, you are also teaching it forward, because we will learn more by teaching. Any feedbacks and suggestions if you have for CSR box team as well as me, please let me know. So the data file, what you need to upload is the data file that you will use in your project. Okay. CSR box team, the people are asking for project submission deadline. Please tell them what is the deadline to.
Yes, Amit. So you students, you have the weekend to work on it. So we are expecting the submission by November. Sorry. Yeah, we are expecting the submission by November 3rd. Um, if you so please don't, I know it's holidays, but try working on your submission and finish it off by November 3rd, as that is our 2 week internship. That's how it comes to an end. So make sure that you submit your learning plan certificate as well. It's kept open so that those of you who haven't completed your learning plan, you can complete it during this weekend and submit it, as well as your final deliverables. Please ensure that it is submitted by November 3rd. All right, just putting in a reminder, the date is November 3rd. Amazing. Okay, thank you, Amit. Thank you all so much, and over to you, Amit.
Thank you so much, Anne. And please submit all of your documents on time. I know it's holiday season, and also before going, I wish you very, very happy Diwali and a really, really, really safe Diwali. Please enjoy it as much as you can, but keep learning and keep inspiring. You have inspired me throughout this journey. Maybe you can inspire someone else. Thank you so much for joining me in this journey. I will be open for questions now. Those who have marked attendance and those who do not have any questions can leave and enjoy the rest of the evening. Shubh Diwali. Happy Diwali for those who are wishing me on the chat box. Happy Diwali. Thank you so much. Thank you so much. You have been wonderful. All right, so let's get back to problems. So first one is in K nearest neighbors, the visualizing the training set SC is not defined. So you need to define SC somewhere, which is here. So you need to do the feature scaling first. So here you need to do the standard scaler and you need to define SC here. So please check if your code is like this. Visualizing will not be working for K nearest neighbors because of the complexity of the graph. So that will not be there. Okay. I will share the problem statement in WhatsApp. Okay. Thank you so much, everyone, for wishing the festival greetings. And only those people who have errors can be in this session now. Those who want to be, you're free to have be in the session. Okay, so Instra is asking me to show the logistic regression flows. So logistic regression was here. Let's go to Collab. And let's go here. Logistic regression we did today only. So this will be here. Okay, so Instra is having an error. Instra, can you please share your like the screenshot of it? Bharadwaj is saying that if we work as a group, where can we include the member names? So here only in this form, just include the member names here. Okay, no more than 4. So 4 names here. No more than 4 names should be there. No commas, just your names. Okay. So Insha's error is here. She's predicting yes, access 2 features, but standard scaler is expecting 1 feature as input. Can you show me where you have scaled your features? Okay, not just the error. I will able to identify the error if I see the code. Abhijit is sharing his error, which is getting like this. If you are doing it for logistic regression, SC is not defined, right? So SC should be standard scaler, and you need to define it here where you are doing feature scaling. So here please define SC as standard scale. So if you define it here and run this code cell, I think your error will be met. Sai is asking from where we need to take the data set for the project. So you can take the data set from Kaggle. You can make your own survey and make the data set. You can use data sets from some research paper. You can use data set from Google, but make sure that it is a valid data set. That means that you are taking a valid data set from a valid file, valid site, and that should be also in the licensing should be open. That means that we are not using some copyright to this. Please check that also. When I add SC, but now it shows that X train is not defined. So X train is not defined. Your error would be like if X is capital. Okay, so Swapnil is asking me this question that X train is not defined. So here it would be capital. So you need to keep it small. Hemant is giving me this error where no, you can't make svm.inverse transform. You need to make sc.inverse transform. Okay, so Hemant, You cannot inverse transform on support vector machine. You can only inverse transform on standard scalar. So basically you are scaling it back. Inverse transform means that you have scaled something and now you are scaling it back to its original scale. So please take SC here. Sir, can you share a screenshot of which topic we need to make a model? I will not share a screenshot, but I will share you a whole PDF file. So you'll get this PDF file under topics that you can make your projects on by today itself. Okay. In feature scaling, it is showing X-train is not defined. So you need to, Swapnil is saying that you need to run all the codes from here. Go to runtime and run. Okay, so run all the codes. Then it will I think SC is defined here. So SC is defined, and I think the error is in RAM only, where it is not taking the above data sets. So just don't visualize it. Visualizing will take more time. Just rerun the code once. In Insta, you can just go to runtime, run all the code, and check if the error is removed. Yeah, run all. Of the training set, my training set is this. Thank you, Vishnu. Happy Diwali to you too. Thank you so much, Akshay. Happy Diwali. Thank you so much for being in this session. Yeah, Inshra, I'm still here. So run all, run time, run all. Just do this. Can you make a copy of this? So Inshra, if your error is still there, you make a copy of this and then run that copy. Maybe the IDE is corrupt in some way or other. Inshra is saying that more errors erupted. Okay. So just make a copy of this and run it there. Let's see if that runtime environment is working. Kunjam is saying that where can we get the sample data? You can get the sample data from Kaggle, from Google, from research papers, from our own surveys and results. So you can get the data. Kirtana has an error, which is same error, and is taking the code is fine. Like the code is fine. There is no problem in code. Monica is sharing. Anshra is saying that I also have error in KNN. You will have error because for KNN you will not be able to visualize. Monica, your screen is like this. You are having a graph like this. Can I see your code? How you develop this? Okay. If you can see your code, then only I will be able to find. Some more questions. Javed is asking, how can I fix the errors? Javed, I need to, yeah, 2 students can submit single project. Yes, they can. Individually, you can make project. You can also make projects together. You can also make, but only 4 people should be the maximum. Monica is sharing me the code, which is fine up till here. Okay, so you are fitting and transforming X train, but you are not fitting it on Y train, right? But no, sorry, you have fit. This line, I think, is strain is SC dot fit transform X strain and and the code looks fine to me, like everything is fine in this code. It's fine. Transforming this also. Maybe just wait. Like I see if we are transforming this and yeah, so you transform X tray, then you transform X test, and transform it here. So can you just transform it above, like only once, and not transform it again and again? Because when you are transforming it here, no, so it is normalizing everything again, then fitting everything again and normalizing again. So there is a double normalization. So just remove it from here and just transform it above on. Okay. So here, don't transform it again. So just do the inverse transformation. So Monica, your error will be removed. So you're transforming it again. That means that you have already normalized it. Once you are normalizing the normalized one, then you are getting some other data. So just normalize it once and you're ready. Thank you so much, Harshvardhan, for your wishes. I also wish you the same. Javed is having an error and the error is SC is not defined. So KNN you will not be, so you are doing KNN, right? So KNN you will not be able to plot this graph. It will not be, you will not be able to because it is a complex algorithm and you will run out of your memory if you do this. So KNN, you will not be able to visualize this graph. You will be able to visualize this graph only for logistic regression. Sankirtana is sending me again. So SC has no attribute. If you are doing it for KNN, then I'm sorry that you will not be able to do this, Sankirtana. Only logistic regression you will be able to do this. Okay, because it will be difficult for KNN to predict this graph. You need more resources. So do it in Jupyter Lab, it will work there. Inshira, if you're doing it for KNN, then it will not work. It will still show error. If you're doing it for logistic regression, that is fine. For KNN, do it in your own machine by doing it on Jupyter Notebook. Can you please tell about the final project? I have already told about the final project last. I will tell it one more time. So you need to make a project on any of these sustainable goals, any of these 17 sustainable goals, and you need to choose a problem statement. Suppose you choose zero hunger. So you make a AI solution to predict crop yields and optimize farmer yield. If you choose good health and well-being, that means that you are predicting some disease, whether the person has a disease or not. If you choose climate action, then you make a, a predicting model, whether the earthquake or whether the tsunami or any other natural calamity will be there or not. If you choose clean water and sanitation, you predict whether the water is clean or fit for drinking or not. So basically, you have to choose any of the problems of these 17, make your own problem statement, and then design a machine learning model on that. Okay, what you need to submit is 3 files. One, the concept node, your problem statement, why you choose the problem and the solution, the data set in CSV format, and the code in .ipynb. Okay. Ashwin, your problem is similar to what Monica's problem is. That means that you are again fit transforming your SC. So you need to stop doing it twice. So once you transform it here, here you are scaling it. So somewhere you are also scaling it here. So you don't need to scale it here again, or maybe you are scaling it again and again. So if you have pasted this code twice, feature scaling twice, then it will create this problem, this graph like this. Shifty is asking, can we do any other projects other than the 17 problems? No, you have to choose any of these 17 problems only. Okay. All right, it's time for me to go. I have to reach